Greetings and welcome to lesson 2.3, Multiplication Property of Equality. We're going to begin to solve for linear equations, and one of the properties that comes in real handy is the multiplication property of equality. For the multiplication property of equality, what it means is for any three algebraic expressions, A, B, and C does not equal 0. If A equals B, then A times C will equal B times C. In other words, multiplying both sides of an equation by the same non-zero number will not change the solution set. That by no means that it won't change the way that the problem looks, but it won't change the solution set. So suppose we want to solve 5x equals 30. Then we can use the multiplication property of equality to multiply both sides by the reciprocal of the coefficient in front of x, in this case 1 over 5, so 1/5. We can multiply both sides to that using our multiplication property of equality, and we would have 5x equals 30 becomes 1/5 times 5x equals 1/5 times 30. Well, 1/5 times 5 is just 1x, which is a great thing because we just want to solve for x, so now we have isolated x, equals 30 over 5. 30 over 5 we can reduce to 6, so x will equal 6. We can plug 6 back in just to double check our answer. 5 times 6 does indeed equal 30. So let's take another problem. We'll solve for a. Negative 4a equals 24. This time, my reciprocal that I want to multiply is negative 1/4. So I'm going to multiply both sides by negative 1/4. And by doing that, it's going to be negative 1 times negative 4. 4 times 1, that's negative 4 over 4, which just becomes a big 1. 24 times negative 1 is negative 24. 1 times 4 is 4. Now we can reduce 24 over 4 to 6. And negative 24 over 4 reduces down to negative 6. I think I already said that. All right. So when we're multiplying by the reciprocal of the coefficient, we will guarantee that the variable in front of the variable will be 1. Therefore, the variable will always be isolated. Now, it might not always be obvious what we need to multiply it by. But if we always do the reciprocal of whatever the coefficient is, we're guaranteed to get 1. For example, let's solve for t. Negative t over 3 equals 5. Well, it may not be obvious what the negative t over 3, what the coefficient is. So why don't you break apart the number and the variable? Well, that becomes negative 1/3 t equals 5. The reciprocal of negative 1/3 is negative 3. Negative 3 times negative 1/3 will be a 1. But remember, what we did to one side of the equation, we need to do to the other side. So we need to multiply the other side, the right-hand side, by negative 3. So our final solution is t equals negative 15. So I have a few more examples I want to run through quickly. 2/3 y equals 4. The reciprocal of 2/3 is 3/2. And 3/2 times 2/3 will get us the 1. We multiplied the left-hand side by 2/3, so we must multiply the right-hand side by 2/3. So now that the left-hand side is just y, 3 times 4 is 12, and then 2 times 1 is 2. But 12 over 2 is 6. So y equals 6 in this case. Now, problems can get a little bit more complex by combining similar terms, and then you want to isolate the variable. So the first thing we're going to do is combine similar terms. we have coefficients, or we have constants, I should say, 5 and 8. And on the right-hand side, I have variables 10x, 20x, and negative 4x. I'm going to combine all the x's together. I'm going to combine all the constants together. 5 times 8 is 13, and 10 plus 20 is 30, minus 4 is 26x. Now remember, we're just looking at the variable and the coefficient in front of the variable. So the coefficient in front of the x right now is 26. The reciprocal of 26 is 1 over 26. So if we multiply both sides by 1 over 26, we're guaranteed to isolate the variable. All right, so multiply both sides by 1 over 26, and we get to 13 over 26, but 13 over 26 is 1/2. So x equals 1/2. Okay, and I do suggest you try these out on your own. Practice always makes you better at math. All right, again, we're going to combine like terms, we're going to isolate the variable, and then we'll build up to the answer. So our original problem is 6x plus 5 equals negative 13. Well, the first thing I need to do is get 6x all by itself. So the first thing we need to do is get rid of this adding 5. The reverse of adding 5, using our addition property of equality, we're going to subtract 5 from both sides. So subtract 5 and subtract 5. Now I'm going to have 6x equals negative 18. But I don't want to know what 6x's are worth, so I'm going to multiply both sides by the reciprocal of 6, and therefore I have x equals negative 18 over 6, but negative 18 over 6 is negative 3. You're going to use the same process over and over and over again. Move all of the constants to one side, the variables on the other. Isolate the variable, and there you would solve for your variable by isolating it. 5x equals 2x plus 12. Well, I have x's on the left, I have x's on the right, I want to put them together. So I'm going to move the 2x by subtracting 2x on both sides, giving me 3x equals 12. Now again, I want to isolate my variable, so I'm going to multiply each side by 1/3, the reciprocal of 3. Once I do that, x equals 12 over 3, which equals 4. Now here's another problem that I just want to share with you. I'm not going to work through it. You can see how it's done to work through it. But again, I have variables on each side. So I have 3x and 2x, and then I have constants on both sides. And basically you're going to choose which side do the constants go on, which side do the variables go on. It really doesn't matter. Your solution set is going to be exactly the same solution set. The only difference is you might have to work with negative numbers by doing one way versus the other way. Now, working with fractions, I know nobody likes to work with fractions, but the same process when we're working with fractions. The only difference is when you add fractions, you have to find common denominator. When you're multiplying, just take the reciprocal of the coefficient in front of x. Same thing. All right, so let's try 2/3 x plus 1/2 equals negative 3/4. First thing I want to do is have all of my variables on one side and my constants on the other, so I need to move the 1/2. Once I move the 1/2 to the other side, I'm going to add the opposite. So in other words, I'm going to subtract 1/2 or add a negative 1/2 to both sides. I do need to find common denominator. So that goes away. The 1/2 is now removed from the left-hand side, and it is moved to the right-hand side. But my denominators are not the same, so I have to find common denominator. Once I have common denominator, I can combine like terms. So I have negative 3/4 plus a negative 2/4, giving me a negative 5/4. So my new problem I have is 2/3 x equals negative 5/4. I'm going to take the 2/3, my coefficient in front of the x, and I'm going to multiply by its reciprocal. Flip it. 3/2. So if I multiply both sides by 3/2, that will isolate my x. 3 times negative 5 is negative 15, and 2 times 4 is 8. That's the answer. That's one method. And a lot of people don't like working with fractions. They don't mind working with larger numbers, but they don't like working with fractions. So there's another way of solving the same exact problem, but the first thing we're going to do is eliminate the fractions. By doing that, the first thing I need to find is the LCD of all the terms. So for 2/3 x plus 1/2 equals negative 3/4, my denominators are 3, 2, and 4. I'm just going to do the prime factorization of each. 3, the primes in 3 is just 3. 2 is just 2, and 4 is going to be 2 times 2. To find the LCD working with the primes, you just take all the primes well, how do I word this to make sense? You take the most of each number that you have. So I have 2's factored and I have 3's factored. And what I mean by that is on the right-hand side where I factored them, I have factors of a 3 and I have factors of 2's. Well, I take as many 2's as I can. 4 broke down into 2 times 2, so I have 2 of them there. 2 broke down in just 1 2. Well, the most 2's that I have are 2 2's, so I need both of those 2's for my LCD. And then 3, I have 1 3. Nobody else has a 3, but I have to bring this 3 along. So my LCD of 3, 2, and 4 will be 2 times 2 times 3, which equals 12. So I found my LCD of 12. Now what do? I multiply each side of my equation by the LCD, and I mean the whole entire side. In other words, each term gets multiplied by this 12. So the left-hand side gets multiplied by 12. The right-hand side gets multiplied by 12. Now the interesting part about this left-hand side is I have to distribute the 12 to each of the terms in the parentheses here. And therefore I have 12 times 2/3 x plus 12 times 1/2 equals 12 times negative 3/4. Now either you can multiply this out and then reduce, or you can, if you see that you can reduce now, great. So I see I can reduce now, so I'm going to reduce 12 and 3. 3 goes into 12 4 times. 2 goes into 12 6 times. 4 goes into 12 3 times. So now my new problem is 4 times 2x plus 6 times 1 equals 3 times negative 3. This all reduces down to 8x plus 6 minus 9. No more fractions. It's the same exact problem as we started off with. It just looks different. That's all. It's the same exact problem. 8x plus 6x equals negative 9. First thing I'm going to do is move all constants to one side and the x's to another side. So subtract 6, 8x equals negative 15. Using the multiplication property of equality, I'm going to multiply by the reciprocal of 8 to both sides, and therefore x equals negative 15/8. Now, some of you may have learned that we can just divide by what's ever sitting in front of x. And in essence, we're doing that because the definition of division is multiplication by the reciprocal. So dividing by the coefficient of the variable is totally acceptable means of finding a solution. For example, 3x equals 18. I'm going to divide each side by 3, therefore x equals 6. And because of the definition of division, this is completely acceptable. Dividing by 3 is the same thing as multiplying by 1/3. Same thing. So that's it for this lecture. Until next time, be seeing you.